Okay, we're going to look at factoring the difference of squares. So in math, difference means subtraction. And when we say the difference of squares, we're talking about perfect squares. Now, when you have the difference of squares, it's going to be a binomial, which means it's going to have two terms. Both of those terms are going to be perfect squares, and they're going to be subtracting between them. It's going to be a subtraction sign. So let's talk about what a perfect square is. First, we can make a list of our perfect squares. Perfect squares are numbers that we get when we square a number. So when we square 1, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared, or 4 times 4 is 16, 5 squared, 6 squared, and so on. I'm going to go ahead and list mine all the way up to 144. Now they keep going after that. But this is probably enough for us to get a good idea of a list of perfect squares. We can also have some variable terms that are perfect squares. X squared is a perfect square because it comes from multiplying x times itself, or squaring an x. X to the fourth is a perfect square because it comes from multiplying x squared times itself. X squared times x squared is x to the fourth. Remember, when we're multiplying, we add our exponents. The next perfect square would be x to the sixth. That comes from x cubed times x cubed. The next one would be x to the eighth, and so on. Now you can see the pattern here. If the exponent is even, then it's going to be a perfect square. So the next one would be x to the 10th, x to the 12th, and so on. And again, these don't have to be x's. They can be any variable, a squared, b to the fourth. Any of those would be considered perfect squares. So here's what a difference of squares might look like. Okay, so when we're factoring and we see that we have two terms, we want to check for difference of squares. So this is a perfect square, 25 is a perfect square, and they're being subtracted, so that means this is the difference of squares. So when you have the difference of squares, it's going to factor to two binomials. Since this is y squared, the square root of that is y, so y times y gives you y squared. The square root of 25 is 5, so 5 times 5 gives you 25, and it's always going to be 1 plus and 1 minus. Okay, it doesn't matter what order you put those in. I usually put my plus first. That's just how I do it, but it does not matter. I'm going to show you how we can check that. That's the answer. If we want to check it, we can distribute that, multiply these back together. We want to make sure when we multiply them back together that it gives us y squared minus 25. So we're going to do y times y is y squared. Y times negative 5 is negative 5y. Then we're going to come back and distribute the positive 5. Positive 5 times y is positive 5y. Positive 5 times negative 5 is negative 25. So when we go to combine our like terms, we see what's going to happen right here is that these terms are going to zero out. They're going to cancel each other out and make 0. So all we're going to be left with is y squared minus 25. So that kind of shows you why you need a plus and a minus here when you factor this. By having a plus and a minus, it's going to cause these two terms to always zero out, and you'll just be left with the squared terms, y squared and 5 squared. Okay, so let's do another one. How about a squared minus 64? Okay, once again, you see that you have a perfect square here, a squared, you have a perfect square here, 64, and it is subtraction, so this is the difference of squares. All right, so we're going to draw our two sets of parentheses. We know the square root of a squared is a, so we're going to put a here and here. The square root of 64 is 8, so we're going to put an 8 here and here. And we're going to have 1 plus and 1 minus. All right, let's look at this one. Now we don't want to forget that in any factoring problem, the very first step is to take out a greatest common factor if you have one. So when we look at this problem, we do see that it has two terms. It's a binomial. X squared is a perfect square, but 2 is not, and 32 is not. And that's why we don't want to jump straight to difference of squares. We always want to look at and see if we have a GCF. And we do in this problem. We have a greatest common factor of 2. So I'm going to factor out a 2, which is going to leave me with x squared minus 16. Now, if I examine here what I've got, this binomial, I see that this is the difference of squares. So I'm going to be able to break down x squared minus 16, factor it as the difference of squares. X times x is x squared. 4 times 4 is 16. 1 plus and 1 minus, and this 2 is also part of our final answer because we would have to multiply all three of these back together to get 2x squared minus 32. All right, let's look at one like this. Now there's more going on in this problem, but we really don't do it any differently. We want to check to see if we have a greatest common factor. It does not look like we do. And then we see that it's got two terms, so we're going to check to see if it's the difference of squares. We see that it's a difference, so that's good. For it to be the difference of squares, every single part has to be a perfect square. So we're going to check each part. 49 is a perfect square. A squared, yes, that's a perfect square. 4 is, and b squared is. All right, so this is in fact the difference of squares. When we fill in over here and we take the square root of this, we have to take the square root of each part. So 49 would be 7 and 7. A squared would be a and a. So 7a times 7a is 49a squared. For the 4b squared, we would need a 2 and a 2 for the 4, a b and a b for the b squared. 2b times 2b is 4b squared. Then we would need 1 plus and 1 minus. Okay, let's take a look at this one. All right, again, we always look for a greatest common factor before we do anything else in a factoring problem. And so we do, I've got a little gnat flying around, y'all, sorry. We do have a greatest common factor here of 4. So I'm going to take out the 4. And then I'm going to look at what I have left, and I see that it is a plus sign. This is a perfect square, and 9 is a perfect square, but I have a plus sign in between those. So that, excuse me, is not the difference of squares. This is the sum of squares. And some of you might think, well, I bet that'll factor, and you might try to factor it, but you will not be right because the sum of squares cannot be factored. So I'm going to show you over here. This is the final answer, guys, for this problem. I'm going to show you over here what the common mistake is. So a lot of people will take that 4 out. Let's write right here, mistake. Don't think this is correct. And they'll say, okay, well, surely this will factor. X times x is x squared, and 3 times 3 is 9. And since this is a plus, most people think, well, this should work. Okay, well, I'm going to show you if I distribute these two out and multiply them back together, it's not going to give me x squared plus 9. So let's look. X times x is x squared. X times 3 is 3x. Then I come back and I distribute the positive 3. Positive 3x plus 9. You see here that my middle terms do not cancel out. They do not zero out. I would end up with this times 4. And so that's not going to give us what we started with. So this is going to be incorrect. Okay, so you cannot factor the sum of two squares. You can only factor the difference of two squares. All right, let's see. Let's do one more. All right, so we see here that we have a perfect square here and a perfect square here, and it is subtraction. So this is the difference of two squares. So we're going to break that down. W to the fourth, the square root of that is W squared. So I'm going to put W squared and W squared. We multiply that back together, it gives us W to the fourth. The square root of 81 is 9. So I'm going to put a 9 and a 9, 1 plus and 1 minus. Now, we're good so far, but we're not finished, because if you notice, this second factor is the difference of squares again. W squared is a perfect square. 9 is a perfect square. Now this is the sum of squares, and we just talked about how the sum of squares will not factor. So we're just going to bring that factor down as it is, leaving it as it is, but we're going to break down the W squared minus 9 because it's the difference of squares. W squared will break down to W times W. 9 will be 3 times 3. We'll have 1 plus and 1 minus. So this is our final answer on that problem. So you always need to look once you've factored and make sure that there's nothing else that you can do. All right, so that is the difference of squares.